All right. So the red curve and the blue curve are inverses, and this is the line y equals x right here, right? And if they're inverses, they're reflected about the line y equals x. And also, if I picked a point here, and maybe I called it, let's say, maybe a comma f of a. Seems like a good name for a point. And then it is not alpha. Then what would this point over here be? If the first one is a f of a, I think it's the inverse f of a, right? If I want the inverse of a point, I just change the x and y. That's literally what reflection about y equals x means. Just change the x's and y's. Okay? Any questions? We're not. No. Yeah. 1 over what was it? The square root? Square root of 1 minus x squared. In the place of x, though, is actually x squared. Believe it or not. So x squared, that quantity squared. And remember, now we've got to multiply it by the derivative of x squared, or multiply it by d dx of x squared. And so we just simplified a little bit there, end up at 2x over that mess, and that's all. Is take the derivative of this thing. So we'll say v of t, the velocity of this particle, at some time t. Oh, derivative of inverse tan. Well, I remember from the notes about 2 seconds ago that this is 1 over, what do we say, 1 plus x squared? But, whoa. 1 plus, but in place of x is square root of t, right?
Yeah.
That thing's squared.
Yeah.
Times the derivative of whatever is in here. What is the derivative of that? 1/2 t to the negative 1/2. Yuck. Make it look a little nicer. This is v of t then equals 1 over 1 plus, I think, t, right? Times 1, we'll say 1 over 2 square root of t. Is that okay? At t equals 16, so I want the velocity at t equals 16, so I just want v of 16. And v of 16, I think, is just 1 over 1 plus 16 times 1 over 8. Okay, and then what is, let's see, 17 times 8 gives me 1 over...
No, just kidding. I was thinking of 7.
Right, 1 over 136, and that's it. So that's the velocity. It's moving pretty slow. Of course, we have no units on this problem, so we don't really know. Maybe it's 1 over 36 light years per year. No, wait, that doesn't work. Here we go. Derivative of... Whoa! Uh-oh. All right, derivative of the inverse secant, f prime of x, here we go, equals 1 over the absolute value of, okay, whoops, I almost wrote x, but remember, we know that it's not x, it's whatever's in the parentheses, which is 5x to the 4th. Right? Okay? All right, and then times this, if I remember right, the square root of, I think, x squared minus 1. Is that right?
Yeah.
Okay, x squared minus 1. Remember that that's actually 5x to the 4th squared minus 1 times the derivative of the inside, which I think is 20x to the 3rd. All right. The absolute value of 5x to the 4th, isn't that just the same as 5x to the 4th since it's never negative? Yeah. So I think that we could rewrite this as 20x cubed divided by 5x to the 4th times the square root of, let's see, that's going to be 25x to the 8th minus 1. And then if we simplify a bit further, I think we're going to get on top just 4 divided by x times the square root of 25x to the 8th minus 1.